Hello everyone. In this lecture we will start our new subject method that is refrigeration and air conditioning. It is also known as short form by RAC. Okay. This RAC is for will be for discuss according to Gates syllabus and also will be applicable for B.Tech students. Okay. Now first we will start with refrigeration. Refrigeration. Okay. So if we talk about refrigeration, first of all we will see what is definition of refrigeration. Okay. So refrigeration, it is a process of reducing the temperature of the closed space below ambient temperature, and maintaining it at that temperature. That okay. So in refrigeration, but it is a process of reducing the temperature of the closed space below the ambient temperature. Okay, and we have to maintain at that temperature only. Okay. Now the temperature which we want is generally dependent on our particular application. Okay. So now we can see some applications of refrigeration. Okay. So in this topic we will see applications of refrigeration. Okay. So if we are talking about refrigeration, we can like say that the refrigeration might be used. Our what is the most common we say ways refrigeration is used in household, or we can write like first. Let's say that we know that our refrigeration system is used to cool water. Okay, and it can be further also used to cool your air in the room. Okay. So the that is called air conditioning. Okay. So application is auditorium, theaters, hospitals, etc. Okay. Okay. And these are quite large scale refrigeration scale. Okay. Now if we can also like talk about our domestic refrigerator, including your refrigerators and home freezers. Okay. And this domestic refrigerator are very small in size. Okay. And having a refrigeration effect of around 300 to 500 kilowatt sorry watt. Okay. And the evaporator temperature is generally maintained at -5 degrees Celsius. Okay. Now we can see a third operation, that is we can say that it is for storage units, refrigeration in storage units. Some examples we will see. Let's say milk. We know that chilling plant milk chilling plant. Okay. But another example we can talk is like drink storage soft drink. Okay. Next we can also talk about vegetables and food products, vegetables and food products. Okay. So these are few applications uh, of refrigeration. Okay. Now there are some type of refrigeration system. Okay, we will see what are the various type of refrigeration system. Okay. So we can see types of refrigeration. Types of refrigeration systems. Okay. Now there are basically three types of refrigeration system. First is we known as non-cyclic refrigeration system. Non-cyclic refrigeration system. Okay. Okay. Now if we talk about non-cyclic, so these systems include your refrigeration with ice, using ice. Okay. Or we can also use evaporation with refrigeration with with the help of evaporation. Okay. We can also take by refrigeration by using dry ice. Okay. So these systems are used before the invention of our cyclic refrigeration system. Okay. So naturally, for example, if we take that natural ice was used to preserve our flesh during the shipment from one country to another. Okay. And similarly we can also uh, these natural ice are also used for cooling. Okay. During the heat. Okay. During the summers, a large ice block was placed in the palaces. Okay. And it provides with the airflow, it provides the cool air. Okay. So these are our non-cyclic refrigeration. Okay. What happens in evaporation? I think you can get. Okay. So first, let's say using ice. So we generally place the ice inside our cool. Like you generally see in the shops also, where is electricity not available, roadside shops. So there, what happens that your Coke bottles or your soft drinks are generally kept inside a insulated thermocol box. Okay. And it is filled with your ice. Okay. So this is cooling refrigeration using ice. Okay. Evaporation, what we do. So in summers, if you have seen the clay pot, so you see that when in summers when the clay pot is filled with water, then generally on outside we put a thick blanket uh, or some bag, and we generally pour water on it. Okay. So what happens that on outside there will be constant, due to the interaction of surrounding, there will be constant water vapors will be evaporated from the surface. Okay. And when the water vapor leaves, then the heat inside, how does water vapor leaves, the heat inside is absorbed. Okay. So your clay pot remains cool. Okay. I hope you get this example. Okay. Now using dry ice. So dry ice is actually mentioned to at a critical point of CO2. Okay. So this is basically solid carbon dioxide. Okay. Dry ice is solid carbon dioxide. Okay. And when the use is similar to that of ice, using ice, but in solid CO2, the benefit is that when you put ice in the system, the ice will melt into water. Okay. But solid CO2 will directly evaporate. Okay. It directly convert into your gas form. Okay. So next, if you talk about the second type of refrigeration system, it is cyclic refrigeration system. Cyclic refrigeration system. Okay. So if we talk about cyclic refrigeration system, we can talk about air refrigeration cycle, air refrigeration cycle. We can talk about vapor compression refrigeration cycle. Okay. Now we can also talk about vapor absorption cycle. So these three cycles we will study in detail in the further chapters. Okay. One by one. And if we talk about the third type of absorption system, so we call it others, other type are collectively called as other refrigeration systems. Okay, what does this include? This include your sorry. So this include your processes like thermoelectric refrigeration, thermoelectric refrigeration. This thermoelectric refrigeration your uses the Seebeck effect and Peltier effect. Okay, I have mentioned in your thermodynamics. Okay, so this uses uh, Peltier effect and Seebeck effect to generate low temperature. Okay, we can talk about steam jet refrigeration, steam jet refrigeration. Okay, next we can talk about vortex tube and all others. Okay, so basically so how does the refrigeration system is uh, divided on the so the first is non-cyclic refrigeration system. It is using ice evaporation and using dry ice. Second is cyclic refrigeration system, which is air refrigeration cycle, vapor compression refrigeration cycle, and vapor absorption cycle. Okay, the third is all other type of your refrigeration systems are converted into third form. Okay, third type. Okay, collectively call it third type. So these are thermoelectric refrigeration, steam jet refrigeration, and vortex refrigeration, and many more. Okay. So with this we have like completed our topic, refrigeration system, type of refrigeration system. Okay. Now if we move, now let's talk about unit of refrigeration, or we can also call it as rating for refrigeration. Okay. So if we talk about unit, so our SI unit is standard unit of refrigeration is standard unit of refrigeration is ton of refrigeration, TR. Okay, that is ton of refrigeration. Okay, and this is denoted by, of course, TR, as I mentioned. And this one TR can be defined. Let's talk about one TR. So one TR definition we will see. So this is represented by, this is defined as amount of heat amount of heat added to ice to 1 ton, or we can say that, okay, one small ton small ton of ice at 0 degree Celsius to convert it into water at 0 degree Celsius in 24, okay, in 24 hours. Okay, so it is basically 1 TR is the amount of heat that is required to add to a ton of ice at 0 degree Celsius to convert it into water at 0 degree Celsius in 24 hours. Okay, or it can be also be referred as that the amount of heat need to be removed from 1 ton of water at 0 degree Celsius to convert it into ice at 0 degree Celsius in 24 hours. Okay, so I can write 1 TR is equal to, okay, so we know now this one small ton is equivalent to, this one is small ton is equivalent to 907 kg is, or is 2000 lb pound. Okay, now to calculate 1 TR we have to like total calculate total amount of heat to solidify liquid into, or to melt ice into water divided by time. Okay, now we know that q melt, if we talk about, so q melt is given by mc delta, since this is a phase change process, so this would be mass into latent heat. Okay, now if we were talking about 1 TR, so 1 into mass is 2000 lb into 144 BTU per lb is our latent heat, divided by 24 hours into 3600 to convert it into your seconds. Okay, so we get, or we can like divide it by 60 to convert it into minute first. Okay, so if we calculate 1 T, we get 1 TR is equal to, on calculating this we will get 200 BTU per minute. Okay, but we know that 1 BTU is equal to 1.055 joule, sorry, kilojoule. Okay, so we can directly use this here, so we will get our value as 1 TR is equal to 211 kilojoule per minute. Okay, or we can write it as, after divided by 60 we will get 3.516 kilowatt. Okay, I think you should get this now. Okay, so these three formulas are the important one. Okay, I hope you understood this. Okay, now we will be moving to our next topic after, since we have like covered what is the unit of refrigeration. Okay, and we have understood that what does 1 TR represent. Okay, okay, so next we will be moving to our what is called some basic definitions. Okay, so our first term is refrigeration load. So what is refrigeration load? Refrigeration load indicates the heat needed to be removed continuously from the system from the system to maintain constant temperature. Okay, constant. So let's consider an example like you have put the warm milk into the your refrigerator. Okay, now let's say that the warm milk, let's say this is our warm milk. Okay, milk. So this is, let's say initially it is at 30 degrees Celsius. Okay, now you have put it in refrigerator. So when you put it in refrigerator, what will happen? You will you have added some heat to your refrigerator. Okay, so your refrigerator must reduce this amount of heat, like if your inside temperature of refrigeration, let's say, is at 10 degrees Celsius. Okay, so it must like there will be some heat, so the required heat Q is equal to mc of milk into delta T, that is 30 minus 10. So this amount of heat your refrigerator must remove it. Okay, so this heat removed is known as refrigeration load. Okay, Now it can also be like here if we have calculated it in terms of your kilojoule. Okay, so you can also calculate it in terms of your kilowatt. It is not always, it is generally calculated in terms of kilowatt. Okay, so okay, so you can calculate how much time it would take to this remove this load Q and divide it by here. So you will get your refrigeration load. Okay, now if we talk about similar to this, we have another term, that is heating load. Heating load is when, like in case of in winters we use room heaters. Okay, so what is the purpose? So in refrigeration our purpose was to maintain the temperature lower than the ambient temperature. Okay, but in heating conditions we have what our condition is, we have to maintain temperature more than that of ambient temperature. Okay, so heating load is the amount of heat which must be added. Heat rate, or say we can say heat rate, or rate of heat must added. Rate of heat supplied to maintain constant constant temperature constant temperature of the space. Okay, so this is our heating load, and here I have mentioned heat needed, so it should also be rate of heat. Rate of heat. Okay, this should be q dot. Okay, and the unit should be kilojoule or kilowatt, or your ton of refrigeration. Okay, so I hope you understood these points well. Next we will move to the concept of heat engines, refrigeration and heat pump. Okay, so in our thermodynamics lectures we have studied that our concept of heat engine, refrigeration and heat pump, so we will review that over here. Okay, so here we will be learning about heat engines, refrigerator and heat pumps. Okay, so for this we will draw our cycles. Okay, so in general when I say heat transfer, you get the idea that heat is like heat always we all know that. Okay, that heat always from high temperature to low temperature. Okay, so such transfer occurs naturally. Okay, now if we have to like obtain some other, like we have to transfer heat from lower temperature to high temperature, we have to provide some external input. Okay, so with that we will be like first drawing, I will be drawing all three cycles. Okay, so let's say that there are two reservoirs. Okay, so let's say this is one reservoir. Okay, and here it is, let me draw first. So here our heat engine is attached. Okay, so this is our engine. Okay, now this is our heat source. Heat source at T1. Okay, this is our heat sink, and this is at temperature T2. Okay, now okay, so first let me copy this part. Okay, okay, so we will we will so this engine will take heat Q1 from heat source and provide this heat Q2 to the sink after producing some amount of work. Let's say W is amount of work, and this is in this heat engine. Let's mention it as HE. Okay, now if we talk about refrigeration, in case of refrigeration what happens? if we talk about refrigeration, in case what happens, this isn't the heat source now, this isn't the heat sink, okay. They are just two reservoirs, okay. And this T2 we are talking about will be actually be a closed space, okay. In this closed space, so this T2, in this closed space we will be performing our refrigeration, okay. In this closed space we require a particular amount of particular temperature, constant temperature, okay. And this T1 is our surrounding or ambient, okay. Now what happens here that your system refrigerator absorbs the amount Q to from your space, okay, and supplied the heat Q1 to the ambient along with some work input, okay. And of course okay, now if we talk about your heat pump is exactly similar to, like, its drawing is example exactly similar to this, okay. Let me first copy and paste it here, okay. Now here only difference is that, or we can, okay, so we can copy this, okay. So in heat source, like in the refrigeration, our this was our area of interest, okay, reason, okay. Now here in case of heat pump, this space is our area of consideration, okay. And we have to maintain a higher temperature, okay. Let's say this is a your house, okay, okay. So that will be a T1, and let's say this T2 will be here our ambient, okay. Now the heat of, again, heat Q2 will be absorbed from the ambient, and heat Q1 will be supplied to the your house, and along with some work input W, and this is our heat pump, okay. Now if we write the, like, what will be rating for all three of them, so let me write here. So we, for this we can write, for unit engine we write efficiency is equal to 1 minus Q2 by Q1, or also equal to 1 minus T2 by T1, depending on your value of, like if your refrigerator is reversible or irreversible, okay. Okay, now your COP of refrigerator is given as COP of refrigerator is given as, so I've told you that COP or efficiency both are desired, if desired effect upon energy input, okay. So in this case your desired effect is uh, your lower temperature, okay, or you can say that lower heat, and your input is this W, okay. So you can write it as Q2 by W, or you can write it as Q2 upon W. We can write it as Q1 minus Q2. I think you remember this point, okay. Or in case of like Carnot, we can write it as uh, T2 upon T1 minus T2, okay. I hope you understood this point. And this is okay. Now if we talk about next point, that is for heat pump. So for heat pump we can write COP of heat pump is equal to, again, desired effect. Here desired effect is our higher temperature Q1, okay. Q1 upon W, okay. Now this can be written as Q1 upon Q1 minus Q2, okay. Now this further, this can be written as T1 upon T1 minus T2 if we see this Carnot, okay. Now this, from here we can say that if we solve this, let's say divide up both numerator and denominator by Q1, so we get Q1 upon 1 minus Q2 by Q1 will be equal to here efficiency, okay. So we can write it as is equal to 1 by efficiency, okay. I have proven all these points in your thermodynamics lecture, okay. If you want, you can read your uh, lecture on look into a lecture for second law of thermodynamics, okay. In that I have discussed all these points in detail, okay. Okay, now if we compare, so I have also mentioned, if you compare this COP of heat pump and COP of refrigerator, you get your COP of heat pump is equal to 1 plus COP of refrigerator is equal to 1 upon efficiency. Okay, if you also consider this part also. Okay, now if we we can stop this lecture here. Okay, so in next lecture we will be holding a question section for the basics of our heat engine, refrigerator and heat pump, along with this what is the cooling capacity, questions like what is the cooling capacity, refrigeration capacity. Okay, so as I mentioned here, your refrigeration load, this is also somewhere called cooling capacity or cooling load. Okay, similarly, the heating load, the heating capacity was also known as heating capacity. So we will look into questions in your first question session for refrigeration and air conditioning. Okay, so thank you for this lecture.